Welcome back to Maths with Mrs. J. We're coming towards the end of our logarithm section, and we're finally up to the point where we can actually do some calculus. The really cool thing about a natural log is that the derivative of it is just 1 over x. Very cool. Also, but we're not doing exponential derivatives here, but I'll just point out to you that the derivative with respect to x of e to the x is just e to the x. So that's really cool as well, but we'll handle that in a different video. For now, we're just concentrating on the logs. So the derivative of natural log of x is 1 on x. Now, it follows using your chain rule that if you have natural log of a function of x, the derivative will be 1 over that function, but then you'll multiply by the derivative of the function because of the chain rule, and we'll do one like that in just a minute. If you ever need to do a derivative of a log that's to a base other than base e, then what you need to do is you need to remember your change of base rule, which we've done recently. So log of x to base a, if we change it to base e, will be log of x to base e over log of a to base e. All right, that's changing from base a to base e. Now, of course, we normally write ln there for natural log. So this is the same thing as 1 over natural log of a times natural log of x. Now, this is just a number, all right? When we're differentiating and we have a constant multiplier, that just comes along for the ride. That's why when we differentiate this, we get 1 over x, but we also get times 1 over natural log of a. All right, let's just do a few quick examples here. I'm deliberately picking different terminology just to get you used to the different ways of writing it. If we have y, we can either write dy dx or y dash. I'm going to write y dash just to be a little bit different. Okay, so it's going to be 1 over 2x, but then we're going to multiply by the derivative of the 2x, which is 2. Now, lo and behold, you're just going to get 1 on x. Why is that? Let's think about that for a minute. If we have some general function y equals natural log of, say, k of x, using our log rules, we know that the log of a product is the sum of the logs, isn't it? So that's what we get when we split that up into a sum. The derivative of this, therefore, will be the derivative of this. This is just a constant term. We should know by now that if you have a constant term and you differentiate, you get nothing. So that's why you're just going to get you 1 on x when you differentiate. So in general, you could think of this as a general rule. Any just constant in front of your x there will cancel out because of the chain rule or because of this rule here, whichever way you want to think about it, and you're just going to get 1 on your x. All right, next one, f dash x. All right, well, the rule says 1 over x squared plus 1. Okay, however, the chain rule says we're going to multiply by the derivative of that inner function. The derivative of that inner function is 2x. And for our last one here, we have a product rule coming in. Remember, product rule, you can't just differentiate this, and multiply by the derivatives. It's not going to work. So you're going to have first thing times derivative of second thing plus second thing times derivative of first thing. Remember that, u dv dx plus v du dx, that's your product rule. All right, now nicely these cancel off and you're left with a 1, and 1 times natural log is just natural log. And there we have it. This one is actually a really useful one that's often used for anti-differentiating. Quite often with a more complex integration question, they'll get you to differentiate something first and then they'll say, now use that to find the antiderivative. So just bear that in mind. We're going to do antiderivatives in our next video.